Yep, started. Over to you, Ravi.
Great. Thanks, Abhirami. So, as we discussed, first let's briefly understand what is influencer analytics and why is it gaining popularity of late. So, as you know, with general large language based applications like Bard or even ChatGPT, when you go to these applications and ask questions like generate me an essay on AI or give me the recipe for masala dosa, etc., they do a great job and they give you very compelling and convincing answers. Primarily because all of this data is publicly available and they have been, in a way, trained on this data. But if you were to ask Bard questions on data that is only privy to me or you or to the organizations that we work, for example, like how many leaves am I eligible for if I'm working for company X, or what is the travel limit that I'm eligible for if I'm a software engineer at company X. Now, these are the data that is not publicly available. And so, whatever responses that we would get in Bard or even ChatGPT would be hallucinated ones and not the actual ones. So, if you imagine our day in the lives, to get these answers, we go to our internal travel portal or HR policy portal, scroll through multiple PDFs, and then find out what is the leaves that I'm eligible for or what is my travel limit, etc. Now, imagine instead of you doing all of this, if you had Bard kind of interface, and then if that Bard kind of a model would be able to answer questions only from your organizational data, like your HR policies or contracts, agreements, etc. So you could just type in questions as you would do in Bard and ask questions like how many leaves you are eligible, and then you would get answers instantaneously, and those answers would be accurate as well. Similarly, let's say if you are into legal profession and if you are validating contracts or agreement documents, which could be running into hundreds of pages, it would be a very cumbersome process to manually go through all of the documents, find out who are the parties involved, what are the terms and conditions, etc. So instead of manually going through all of that, imagine if you have Bard kind of a solution, which is integrated to only those documents of contracts and agreements, and it can answer any question that you ask from that. For example, parties involved, terms and conditions, etc. Now, wouldn't that be extremely exciting for you in a way to automate all of those process and increase their efficiency and automate a lot of things? Now, just as we talked about documents and building or sourcing data from only those documents for the LLMs, as you know, with organizations of late, there is a lot of video and audio related data that is also getting generated, especially post the pandemic. All of these knowledge related sessions or trainings, they have gone virtual, and organizations have a lot of training videos inside their repository. So, as Abhirame mentioned, first time around, it is good to go through the videos and understand the concepts being taught. But second time around, do you really want to go through all of those videos again and understand what the speaker told about BigQuery or what the speaker talked about Gen AI with video analytics, etc.? Rather than going through the videos again, imagine if you can get the transcripts, that is the text output of whatever I'm speaking. If you can get those transcripts, which is primarily a text format, and if you can put those text as a source and then tell the LLM model to only answer questions from that text. Now, with that, you would then be able to answer or retrieve any question, any answer for the questions that you ask from that particular video. So let's say you have a 3-hour deep learning video. Instead of going through again and again, the first time you go through the video, the second time around, you just take the transcripts, push it to the LLM, and then ask questions from the LLM, and then you will be able to get the answers. That way, you will be able to find insights at a few clicks of a button without having to review the entire thing. Now, because we're talking about videos, again, as you know, YouTube is the largest public sourcing video platform out there. And even in YouTube, you would go through a lot of learning videos. So you could again use the same concept there, get the transcript and ask the LLM to retrieve answers from that. So talking about YouTube, as you know, whether we uh, take about watching any movies or buying any gadget or subscribing to an upcoming stock, we do follow a lot of influencers on various social media platforms like Twitter, Facebook, Insta, etc., and even in YouTube. In YouTube, if we can take in particular, these influencers give an in-depth review about why I should buy a particular product, or why I should subscribe to a stock, or why I should not subscribe to a stock, etc. So they give a lot of pros and cons. And apart from our fundamental analysis, their views have a very compelling influence on us, and they make a lot of impact in our buying decisions. So instead of going through hundreds of YouTube videos and understand which product should I buy, if I can just take all of those YouTube video links, pass it to the LLM, and then ask questions from the LLM as to what do the influencers say about the product, I would be easily able to make my decisions in a very automated way. So if I'm a product manager of a company, it would be a wealth of information to know what the influencers think about my product that I have launched, because the influencer's opinion has a significant impact on the consumer's opinion as well. So instead of again going through thousands of videos about various influencers, if I'm a product manager, I would take all the YouTube links, put it to a framework, extract the transcripts from that, and then ask the LLMs to answer questions only from that transcript. That way I'll be able to understand what the influencers are thinking about my projects, about my products, and I can make changes to my products accordingly. I would also be more interested to know what the influencers are thinking about the competing products as well. So that way, getting insights from the influencers, especially from the YouTube videos, would be a great use case. And as we will see shortly, some of these very concepts can be applied to other sources of data. It could be in PDF documents, it could be in Word documents, etc. In fact, there are about 80 other sources that we can connect and similarly get the inputs as well. So my humble request is, apart from your favorite YouTube videos or influencer videos that you would want to review as part of today's session, keep your creative ideas and hats open and do think what is the art of possible here. So that's briefly what influencer analytics is, and how as a solution influencer analytics is different when compared to some of the other solutions that we have discussed. So with that as a context, let's now understand what is the architecture required to build this solution. So to discuss this architecture, I am using a publicly available documentation with Google Cloud. I will ping the link here as well for your reference. So this architecture is primarily based on the concepts of RAG, retriever augmented generation. So one key concept that we understood was that, unlike the general LLM based application where the model can fall back to its foundation training and generate answers, here we are restricting the model to only answer questions from the transcripts of those videos, and it should not generate any response by its own. So if I have to restrict, if I have a YouTube video and if I have to tell the model that you only have to answer from this transcripts of this video, I need to put it in a place and put in some restrictions where all of these checks and bounds can be applied. Now, typically in the databases world, like the Oracle, MySQL, or SQL Server world, as you know, we generally keep the data in a bound format in rows and columns in tables, and then apply a lot of restrictions like table level restrictions, column level restrictions, etc. And then we also build a lot of indexes, just like the index that we index pages of the book that we have, where the index will literally help me to find out which text is there in which page. Similarly, I need to have a store where I can ingest all of this transcripts data, which would help me to contain the data and also enable for faster retrieval of data. So to store all the transcripts of this data and then point the model to that store, we will use a different class of databases called as vector databases. So in the architecture here, you can see there is this box called as vector store or matching engine. This is one of the most popular vector databases. In fact, this is Google Cloud's managed vector database offering. So vector database is where we will keep all the transcripts of the YouTube video, and this is from where we will retrieve the answers. So now that we have understood why we need a vector database, let's take a step back and discover how do we actually go about ingesting my YouTube transcripts to this vector database. So as I mentioned, the transcripts of this YouTube video it will be in a text format. And if you have a longer YouTube video, let's say if it is running to 1 hour or so, the transcripts would of course run into multiple pages. So it would not be prudent or efficient if you just upload that, say, a 20-page document as it is to a vector store or any particular file store for that matter. So for uploading or for storing or for retrieval, as you can easily guess, it is easier, more efficient if I split that particular text into multiple blocks or chunks. So my first step after I retrieve the transcripts is to split those transcripts or text into multiple chunks, which is what is highlighted here. Now, let's say I have 12-page transcripts, and for a very simplistic reason, I split that into 1 page each. So I have 12 chunks, each of 1 page. So these again are still in text format. So the text format per se is not understandable by computers or any of the algorithms for that matter. So I need to convert these text data into a format which is easily understandable by the computers or the algorithms. So to do that, we will use what is called as embeddings. Embeddings is the process using which we will convert the chunks of text into numerical formats. So how does that happen? I'll just briefly explain with this notebook. So let's say I have a text called Rahul likes masala dosa here, and I'm not able to store this data as it is in the vector databases or any database for that matter. So I would take embeddings and then convert this into a numerical representation called as vectors. So here you can see I am using the embeddings function, passing this text and then getting a vector output, which is 768 in length. So basically it's a vector of dimension 768. So once I convert this text, like say Rahul likes masala dosa, or if I take another text, for example, Rahul likes masala dosa for breakfast. So I will also be able to convert these text into embeddings. So the moment I'm able to convert these text into embeddings or numerical format, I will then be able to plot it on a vector space. So as you know, for example, if you have x and y coordinate, places which are similar or close by will be, of course, plotted on the very nearest to each other. Similarly, the sentences which are similar to each other, like in this case, both the statements are very similar, like Rahul likes masala dosa and Rahul likes dosa for breakfast. Because they are similar, they will be plotted very close to the vector space. Now, this is a very key concept which will not only help in storing of the data, but also help in faster retrieval of data. So for now, let's just briefly understand or revisit the concept again. So once I have got the transcripts, which is in the text format, for efficient processing, I will split that into multiple chunks, and then the chunks are still in text format. And I take those chunks and then I convert into a numerical format called vectors using embeddings. And then these embeddings or these vectors, which are in numerical formats and understandable by the computer, is then stored in vector databases. So once I have this data stored in vector databases, the next question that we have to answer is, how do I go about retrieving the data from these vector databases? So now let's say I have asked the LLM model the question that does Rahul like having masala dosas? So the question that is being asked to the LLM model here, because that is also again in a text format, that would be converted to another embedding called as query embeddings. So that would be, now the question would also be converted to a numerical format, a vector of numbers. And once that question is converted to a vector, this vector is then used to compare the vectors that were stored in the vector search. So in the vector search, we had those two embeddings of two statements. This question is then compared with those two vectors, and then the relevant text is retrieved. So in our case, let's say if we have uh, 12 different chunks, and if all of them is giving me different vectors, all of those hundreds of vectors will be stored in vector store. And for the question that I asked, probably only those two vectors are relevant, and only those two vectors will be retrieved from the vector store, and then those are passed as input to the LLM model. Okay, so let's now see what happens when I retrieve those two text only and give input to the LLM model. So I'm now sharing my Vertex AI screen. So once I have connected my text Bison foundation model to the vector store, and I have asked this question like, does Rahul like masala dosa? This question gets converted to vector format. The vector then goes ahead and searches in the vector search, and it retrieves the statements which are relevant to this. So basically, these two statements are returned. And here I would tell the model that you should only answer from the context below, which is the text returned, and do not generate your own response. And if you are asking question anything outside of this context, mention that you are not aware of the answer. So now when I go ahead and click this, so you can see that the model was not hallucinating, saying that does it mean KL Rahul or Rahul Dravid or any other Rahul. It precisely knows that the Rahul was the Rahul mentioned here in this context, and it gave me the response that yes, Rahul likes masala dosa as mentioned in the context. So it is as mentioned in the vector search, or as mentioned in the chunk, or as mentioned in the video. So this is how the entire process works, and this is how all of the different components come and integrate with each other. So I'll just, now that we have understood the overall concept, I'll just now go back to the architecture and explain you what are the different components required at each stage, so that when we go to the code labs, it becomes much easier for you to understand why am I installing a particular package and why am I calling a particular API. So as you can see in the entire architecture, the text bison or Google's foundation model was only used towards the end to answer the question from the context. Apart from that, all the other things are perhaps not a typical Gen AI kind of solution or implementation. So the first thing that you might have noticed is the vector database. Here, we recommend for all enterprise related use cases to use Vertex AI's vector store. It was earlier called as matching engine. For this demo, though, we will be using a lightweight in-memory vector database called as ChromaDB. But again, for all production or enterprise related use cases, please use Vertex AI vector store. And for getting the transcripts from the YouTube video, there are a lot of open source libraries like PyTube, YouTube Transcripts API, etc. All of these are uh, all of these have been wrapped by open source frameworks like Langchain, which give you options to easily integrate about 80 plus sources like YouTube, and without you having to manually install each of these packages. So we will use the Langchain framework to integrate or ingest the transcripts data from the YouTube video. And once the transcripts are derived, to split the transcripts again into multiple chunks, we will use the LangChain framework to split them. And then once the chunks are split, to convert them into embeddings, we will use Vertex AI embeddings or Google Cloud's embeddings approach. And once the embeddings are generated, we would put them into ChromaDB, which is the vector database. And then we will use the LangChain framework again to retrieve the relevant text from this and pass that as an input context to the LLM model. So we will now discuss in detail when we go to the code lab about how all of these components will work and how you can build this entire solution grounds up. This was just a high level overview about how we could actually use a YouTube video, or as I said, any of the 80 plus data sources available out there and build this solution. So with that, let's now go to the code lab. So I'll request you all to please open your code lab and keep it ready, and please show a show of thumbs once we are good to go. Great. I believe the Code Vipassana team is also sharing the code lab link for you, just in case if you're not able to access that. So the introductory part of that as to what is the influencer analytics, we have covered that in fair amount of detail. So I'll skip that. So what you can now do is directly go to the scroll down and you can click on this collab notebook here. So I will reshare my whole screen. My apologies for this. I may have to juggle between my code lab and the collab notebook. So I'll just share my whole window. So I hope you were all able to open your Google Colab notebook. Okay. Uh, One thing that you have to make sure, as Abhirami mentioned earlier, is that this account with which you are logging should be the one that you would have granted access to in your Google Cloud project as well. Okay. So let's now get started. So first things first, we will take all the packages and get it installed. I will explain why we require each of these packages as we go along. So this should take about a couple of minutes to install. So the first package that we are installing is the Google Cloud AI platform. This is primarily required to host or to use my Text Bison Foundation models, which are hosted in the VertexAI platform. The second package that I will be using is the Langchain. This is primarily to connect multiple steps. For example, let's say to ingest the transcripts or to split them to multiple chunks or to retrieve the relevant documents from the vector search and so on. So Langchain is like the glue that connects multiple pieces. That's why we are using Langchain here. Then I'm using ChromaDB. This, as I mentioned, is the vector database that is being used for today's session. It's a lightweight open source vector database. However, we also recommend that we use only for POCs or demos. For all enterprise related use cases, please use vector search in Vertex AI. PyTube and YouTube transcripts API are used to as a backend to ingest your YouTube transcripts data. And then Gradio is the popular open source Python library, which acts as a front end for you to deploy your ML and Gen AI applications. So, and then we are just calling the API AI platform package from the Google Cloud library. So this again in the installation should complete in about 20-30 seconds. Okay, we are done with installing all the packages. Now, after you have done installing, you have to go to the runtime here and click on restart runtime. It prompts you, do you want to restart runtime? Please click on yes. So you can see the runtime getting restarted here. So the runtime is now restarted. Okay, can we please have a show of thumbs if we were able to complete this step? Great. By the way, I forgot to give credits to the collab contributor. This collab notebook was built in collaboration with Tishan Agarwal and the entire code vipassana team here, who did a great job in reviewing the code and modifying it and making it ready for this. So apologies, I missed calling out the credit. So thanks Ishan and the entire code vipassana team for this. So once we have installed and more importantly also restarted the runtime, we'll now have to make sure that the account that we are logging here, which is my account here, this needs to have some roles assigned in the Google Cloud Console in my project. So it is primarily the Vertex AI role. I'm sure you might have already granted this access to a role to your account in the earlier projects. If not, you can go to the Google Cloud Console here, go to IAM, can click on grant access. So you will then give your Google Cloud account from which you have logged into your Collab notebook. And then you will assign the role of Vertex AI user. So if the role doesn't appear uh, here all by itself, this maybe is appearing because I use this role and often, and so that's why it's appearing. If it is not, you can go ahead and type here for Vertex AI user. So you should be able to select this role here and then click on save. I've already done it, so I'll not save it here. So I'll just click on cancel. Okay, cool. So once we have done this, let's now go to the next step.
One second. Ravi, show of thumbs, how many of you were able to successfully authenticate? Just take a second, follow the code lab and complete the authentication step, because if you miss that, you wouldn't be able to follow the rest of the steps. Make sure you're using the same account, the same browser window for both Google Cloud Console and the Collab notebook. Project ID, if it's not showing, pick the project ID from the list, Rachna. If there is no project ID, then you have to create a new project and associate the billing account. All right, we'll give you a minute. For those who have not completed the authentication step, please follow. Ravi, can you show the code lab step?
Sure.
Can you go to the code lab and say which step they have to follow? Yeah, step number 2. Actually, in step number 1, in introduction step, in the end, you have the link to the Collab notebook. Open that in the same browser that you have the GCP console on, the collab.research.google.com/create equal to true. That has to be opened in the same account as your GCP console. Why? Because the account that you use will be dependent on the account that you use for Collab notebook, and you need to authenticate that as well. Now, the step 2 in the code lab, please complete it because Ravi has already completed it. We'll start at 8:15 and continue the rest of the steps.
Sure.
All right, let's go, Ravi.
Okay. So once you were able to authenticate yourself in the Google Cloud Console as well with your role of Vertex AI user, let's now proceed ahead and authenticate from the Collab notebook for us to grant access to the resources from our Google Drive. So once you run this, you will be prompted to ask or allow this. So this is primary asking you or the allow code executed in this notebook to access your Google Drive and Google Cloud data. So you can click on allow, and here again you are prompted as to use which account. So this is the same account by which I have logged into the Colab notebook, and it's also the same account that I've been granted access to my Google Cloud account. So I'll click on this particular account, and it says access to my Google Drive and Google Cloud data. So I can click on allow as well. So that's it. It should go through hassle free. I Can we have a show of thumbs, please, if you were able to authenticate this as well? Okay. So once we were able to authenticate, let's now go ahead and initialize our project. So we will now initialize the project from which we will call the text bison models or the foundation models of Google. So here I need to pass my project ID. So I can again go to my Google Cloud Console. I can select the project ID here. Okay, I was able to initialize my project. Can we have a show of thumbs if you were able to initialize it as well? Okay, in the principle, you should enter the same account that you are using here to log into your Colab, which is your Google account. So now that we have done all the authentication and initialization of the projects, and earlier we had installed the packages, we will now go ahead and import the libraries. So for some of you who are already familiar with some of these use cases, my suggestion would be to also think upon what else can you integrate as a source. And once you get the inputs from this YouTube text, how can you best show them in the form of dashboards or visualizations like in Tableau or Looker? So you can keep thinking and evaluating what are the art of possibilities from that perspective as well. So we will now go ahead and import the libraries. So as we mentioned earlier, to integrate the transcripts, we will use the LangChain framework. And LangChain gives you this uh, method called as document loaders. So under document loaders, we support about LangChain supports about 80 plus different types of sources. So in our case, we are taking the YouTube loader to load the transcripts of the YouTube video. And once we have the transcripts, as we discussed, we need to split the transcript into multiple chunks. For that, we'll be using recursive character text splitters. And once I have my character split and I convert them to embeddings, I convert them to vectors using embeddings. I need to store that into a vector store. For that, I'll be using Chroma. And once I have my data stored in vector database, I need to retrieve the relevant text for my question asked. For that, again, I will use LangChain's retrieval QA chains. I think Polong has already discussed about chains and how easily they're able to glue together multiple tasks one after the other in the session one, if I'm not wrong. So you can please refer to that if you have not done already. And then, of course, Vertex AI to basically call the foundation models. So I'll now go ahead and run this. Okay, I hope we are all able to complete this step of importing the libraries. Okay, so once we have imported the libraries, you probably may not need to install LangChain again because we have covered already that in first step. So we will now go ahead and start initializing the different components required to build the solution. The first initialization that we will do is for the LLM or the foundation model. So here you can see I'm using the Vertex AI library here. The model name that I'm passing is the text Python foundation model. I'm expecting the maximum output tokens to be equal to 256. And because it's a question answer kind of a use case, I don't want the model to generate too many random outputs and be extremely creative. That's why I'm keeping the temperature to be zero point 0.1. As I'm sure it has already been discussed, if you want more exact outputs, you keep the temperature to 0, 0.1 or max 0.2. If you want more creative outputs, you can increase it to zero point 0.7 and onwards. So in our case, we will keep it to zero point 0.1. Now we have initialized the Vertex AI LLM object. Can we have a show of thumbs if we were able to complete this? Great. So once we have initialized the LLM object, now let's call the embeddings, which is primarily used to convert the text into numerical format. Here we have discussed and put together text as to what is chunking and embeddings. We have already covered this in fair details as to why do you require chunks for easy processing and storing of data, and why embeddings is required to convert the text into a numerical format for easy storing and easy comparison of related text. So we will not go to much details about the concepts here. Directly, I'll jump into initiating my embeddings object. So here I'm using the Vertex AI embeddings object. So I'll again copy this code. So you can see, apart from just calling the Vertex AI embeddings, I'm doing a couple of things. I'm saying the query per minute will be 100, and the number of batches of text that would be sent in each embedding process is 5. This is basically to limit the number of rows or the thresholds of creating the embeddings. Sometimes it can give you a rate limiting or rate exceeded, limit exceeded errors. To overcome that, when the text is far too exhaustive, we apply these limits so that the embeddings is done in multiple batches. So I'll now go ahead and initialize my embeddings object. You can see this is the embeddings object that I have now initialized. Can we have a show of thumbs, please? Okay. So we have initialized the LLM model, and now we have initialized the embeddings. We have also uh, invoked all the packages and libraries. So let's go to the next step. So now let's start loading the transcripts of the YouTube video. So for this, as we discussed, we will be using the YouTube loader from Langchain. And here we have taken the YouTube link of influencer who talks about Taylor Swift, who is a great singer and a marketing genius. So you can either take this video, or if you want to test out any other influencers video from YouTube, you can feel free to do that. So I'll copy this code here. So as you can see here, all it is doing is uh, loading the transcripts, and then it is storing that in the results object here. So this should be fairly quick. My video is small enough. Can we have a show of thumbs if we were able to load the YouTube video to the result object? Great. So once we have loaded the YouTube video to the result object, the next step, of course, is to split the transcripts into multiple chunks. So to split that, we will use this piece of code. Now, how do we split? There are multiple ways of splitting, called as just the simple character text splitters or recursive character text splitters and so on. For now, we have used in this demo recursive character text splitters. I will request you to please go through LangChain documentation to understand what are the other types of text splitters and which one would be better in which type of use case. You can just assume for now that I'm just, if I have a transcripts of 15 pages, I'm just dividing that into uh, each one page containing about 1500 characters. So the chunk size here is the number of characters that each chunk will contain. So I will just go ahead and take this code and run this. So you can see it prints the number of documents as 12, basically meaning that the entire transcripts has been divided into 12 chunks, each chunk containing 1500 characters. Okay, thank you for the show of thumbs. So now that we have split the documents, the next step, of course, would be to convert them into vectors using embeddings and then store it into a vector database. So both of this is accomplished in this step here. So you can see I'm passing the docs object, all the 12 docs object here. I'm passing the embeddings object, which will convert my text into vectors. And then I'm passing that to the chroma db object. So this will instantiate my vector database called db. So this is again fairly simple. I hope you were able to pass in the docs and the embeddings and then store it to the vector store. So once I have stored basically the first piece of the pipeline in terms of extracting the transcripts, splitting that to multiple chunks, converting that to numerical format, and then storing that to Chroma or a vector database is now complete. Now we will focus on how can I retrieve the documents from the vector store and pass it as an input to the LLM model. So to do that, the first step that we would configure is Retriever. So in Retriever, basically I am telling or I'm instructing that when you search for the relevant text, there can be multiple types of search. There is something called as similarity search, there is something called MMR, and there is something called similarity score threshold, and so on. So there are certain matrices that are used to find which are the two texts that are similar to each other so that I can retrieve that. Here by default, I will use a simple technique called as similarity. So there are various other techniques that you can also explore in terms of comparing two texts for similarity and retrieving them. So I just paste the link here if you want to know more details about the different types of uh, text similarity comparison. So once I was able to retrieve this, or I'll just create a retriever object. So this should be again fairly simple because I'm using the same DB object that we had created in the earlier step. I'm saying the similarity type should be search type should be similarity, and I want k is equal to 2 as in the top two most probable text to be returned. Can we have a show of thumbs if we were able to complete it thus far? Okay. My request is if you have getting this error, can you see if you were able to restart your runtime after initializing all the packages? Okay. So you should either be able to enable if the VertexAI API if you haven't done that, or if you have done the VertexAI API enablement, you got to make sure that you restart the runtime after installing all the packages. So I'll just go ahead in the interest of time and I'll come back and help you fix some of these errors. So now I have configured my retriever object. So now we will create all the dots one after the other so that it becomes easy for us to retrieve the relevant text. So here we are creating the chain. The chain basically allows you to connect all the dots and help ensure that the entire process is working in a seamless way. So the first thing is I'm configuring the retriever. This retriever is basically connecting to the vector database and getting me the relevant text. And once the text is brought in, it will be passed into the LLM model as an input. And how do I pass the input? I am passing it by stuffing all of this text. So I'll just take 2 minutes to explain what are the different types of chains here. So in this case, in my YouTube, this is probably a 20-minute YouTube video. The transcripts could probably contain about, say, 3,000 odd characters, so which is roughly about 700 tokens, one token being equivalent to 4 characters. So as you know, the input context and the output context have limits in the foundation model. I think we had 4K as a input limit to the earlier VertexAI Bison models. So if I input characters or text which is more than this limit, the model will not be able to process that data and it will fail. It will give me some exceptions. In my case, because it is just a few hundred tokens, I'll be easily able to input all of that as a context and then I will be able to get the response. But if you have a 3-hour YouTube video and if the transcript length runs into hundreds, thousands of tokens, which is beyond the limit of the input tokens for the particular LLM model, you will not be able to put all of that in one go. So to overcome that issue, where you generally what you do is you take chunks of data and put that into the context, which is what we call as map reduce technique. So you pass individual chunks to the context, get the response from the model, and then you summarize all of the responses from there on. So that's slightly advanced concepts that we do in terms of processing large amount of data. For now, for our use case, we just have a single video. So we should be able to stuff all of this text data into the context of the Vertex AI model. So I am giving this chain type as stuff, and then I am passing this as initializing the QA object. Hope you were able to create the QA object with all the LLMs and the QA chains. Okay. So now that we have created the chain object, let's now go ahead and do the most important thing of defining the prompt. As you remember, in the earlier embeddings and vector example, I put those two statements about Rahul liking masala dosa, and then I also put the context or the prompt instruction that you should only answer question from this text below, and you should not generate from any other training or generate your own response. That is precisely what I am passing here as prompt instructions. So the entire thing I am wrapping under a function called smask so that I can easily integrate it with my Gradio application later. So I'll just copy this entire piece of code. I'll explain this again when I run it in the Colab notebook. So here you can see I'm passing the prompt instruction to answer only from the text below. And if the answer is not in the text, say I do not know and do not generate your own response. And this is the QA object, which will be holding, which will be the QA chain, which will be used to retrieve the relevant text from my vector database. And whatever question that I will be asking, that will be passed as an input to this QA chain. So now I'll go ahead and create this function. And as you can see, I'll be passing again the other parameters in terms of temperature, token limits, etc. And this is the LLM predict output, which will be returned to this response. And my answer is then returned with this. So can we have a show of thumbs if we were able to create this function, which is basically just calling the retriever QA chain, passing the question as an input and getting the response back as the output parameter. So once we were able to create this function as well, now we will integrate this function with Gradio, which is the front end open source library used to integrate the Gen AI and LLM or ML based applications. So you can see here the function that we had created here called SM which will be primarily used to you query the retriever QA chain and then query the vector database to get the response. So here I will be calling that function, and to this function I will be passing my question or the input text as a parameter. This input text will come as one of the text boxes that I will be typing my question now. So once you are able to run this function, so you should be able to see this public URL of Gradio live, which will be available for 72 hours. You can click on this Gradio link. Now you can go ahead and ask your question about from this video. So this link is primarily about Taylor Swift or an influencer talking about Taylor Swift. So I'll just go ahead and ask the question on, can you summarize the video for me? So you can see the entire video was summarized, and it shares me the output as Taylor Swift being a marketing genius and a brilliant businesswoman, and details about how she went on to become an American legend in the music industry. Can we have a show of thumbs if you were able to get this response? If you were able to use any of your other influencer videos and get any fascinating outputs, please do take that screenshots and share it with us after the Code Vipassana session. Now here, apart from this summarization video, uh, you can actually go ahead and ask other specific questions. For example, who is Taylor Swift? Let's see. So it is giving me a particular answer that Taylor Swift is an American singer and songwriter. Similarly, you can ask more questions and get the relevant answers which are there only from this YouTube video and not from outside of this YouTube video. So these are primarily text inputs where I'm asking a question and you're able to get the response in a text format. If you wanted to do this for more visual manner, for example, does the influencer, like for example, if it's an influencer talking about a product or a stock market, subscription of IPO, etc. You can take all of those inputs, which are in question and answer format, and then insert that to a database or a data warehouse like BigQuery, and then build dashboards to show in a more visual way to let people know as to what were the things that the user liked about the product and did not like about the product, and does the influencer say for us to buy the product or not buy the product, and how many influencers recommend to buy and not buy the product. So you can do all of those analytics into build over and above this influencer analytics that we have just discussed as well. So if you want to take that as a challenge lab or a challenge assignment, please feel free to do that as well.
That
So
was incredible, Ravi. So we've completed all the steps and you still have the last cleanup step, is it?
I think we're done, Abhirami.
Okay. So if you go to test the solution, so the result for this, we'll come to Q&A in a bit. We are right at time.
Sure,
So let's just stop the recording. And Ravi, if you have some time, if you can hang around for like
sure,
5-10 minutes for
sure,
Q&A, for especially on the pressing ones with the error. But
sure.
meanwhile, can you share the test the solution step of the code lab?
Yeah.
So
So
I'm
for
going to tell you, sorry, yeah, go ahead.
Sure. So for testing the solution, we basically would have to run this code, and this would give you this public URL here. And if you click on the public URL, the Gradio UI opens with the input text and the corresponding output here. So this is where you can go ahead and ask questions like, can you summarize this video, or
Yeah, so this is the kind of screenshot you want to send for submitting the result. Now, if you are feeling adventurous, send us the link to your app. But if you just want to send us the screenshot, don't use a Taylor Swift video. That will not be accepted because you can just get the screenshot from the codelab. So use a new video, upload a new video, or use an existing some other video. Don't use a Taylor Swift video as a result submission. So please try out a different video. Now, this screenshot can be submitted in your uploaded in your Google Drive with access to anyone with the link, and we'll evaluate. Or you can also share the link to the app itself, the deployed link, which you see in the URL, right? .gradio.live. So you can share that or the screenshot, whichever it is, it's fine. But please do share some other video. Thanks a lot, Ravi. This was really useful. And
sure.
I see a lot of engagement today, and there was a lot of interest even before the session started. Sharing the result and everything. Our leads will ping in the chat right now for the form. Everything is available in codevipassana.dev, where to submit, what is the form to submit the result and everything. So go to codevipassana.dev, scroll down. The result submission form is made available there. What is only active for 72 hours? That is not there. It is available till mid of December. But if you don't, no, it won't charge any credit for this because you don't have any instance running. It's just your code lab. It's just your collab where your code is there and you deployed the app only once. Don't try to click the app and call the API, Embeddings API over and over and over again. Just click it once, take the screenshot and share. Be creative with the video you're using. If not, send the link to the app itself. I'll not click more than once for validating. Like the team will not click it for more than once. But if you're feeling like, no, I don't want to share the app link, I only want to share the screenshot, that is also fine. That way, nobody knows your app's link, so don't share it publicly. Just share the screenshot. That is also fine. The link to the form is available in codevipassana.dev. Yeah, https codevipassana.dev. That is the link. All right, now I'm going to stop the recording because we've completed the session, and the recording will be made available probably once the recording is prepared and it's sent to the email. I'll upload it, and it will be made available in the same site, codevipassana.dev. And Ravi has graciously accepted to stay around for 10 more minutes for pressing questions. So let's take that. But before that, if you're in Chennai or if you're willing to participate in DevFest Chennai on December 1st and 2nd, they have given us, especially for our community, coupon code for 15% discount on DevFest thing. So I'll be there on day 2 of I'll be there for a keynote on day 2, and we have one in-person session as well. Only it's purely voluntary. If you're willing to go, then please go. I just wanted to share this coupon code with you, so it's you get use out of it. CV15, code Vipassana 15, CV15. Use it if at all you want to go for DevFest Chennai. All right, now I'll just stop the recording and let's get started with the Q&A.